Thank you, Dr. Beiker. That was fascinating. And we'll take questions at the 2 microphones in the corners there. Thanks.
What are the prospects for a hydraulic hybrid passenger vehicle, and why?
Hydraulic hybrid. Then you might want to explain a little bit more for the audience. Maybe to me as well, what exactly you mean by hydraulic? Like just for the powertrain and hydraulic path in the powertrain?
No, hydraulic power, braking energy storage.
Okay. Well, I think there are different ways how you can store energy, so the motion energy, into a form that you can reuse it once you get going again. I think hydraulics are possible. I think flywheels are interesting ideas. I haven't really done the math, which one is really the most efficient way of storing the energy. I can imagine that staying as much mechanical as possible might actually be a good idea, that you don't have too many conversion factors, but really then you need to figure out what the mass situation with this is, because you need to move this around. I don't have really numbers on this, I'm sorry, but I think it can be a pretty interesting option.
Thank you.
Mm-hmm. I think you have to go to the microphone, because I could hear you, but everyone else couldn't hear you. Unless it's...
You can repeat the question. What about hydrogen?
Okay, what about hydrogen vehicles? And then we go to you over there. Well, hydrogen vehicles, I think, don't have it in my ultimate vision. I think that has a lot of merit. However, hydrogen has 2 big challenges. And I don't think that safety is the biggest challenge. I really think deploying the infrastructure, where do we get the hydrogen from? Right now, it seems to be that natural gas or coal is the best way, the easiest way to really produce a lot of hydrogen. And that obviously releases then the rest of the carbon hydrogen, which obviously then is carbon dioxide. So we don't really gain a whole lot unless we can figure out what we do with the carbon sequestering. And then the infrastructure, how do we get the hydrogen then to the gas stations? Well, we see already that just having people switch from gasoline to natural gas is a huge challenge, where you can very easily transport natural gas if that's liquefied or compressed natural gas to a gas station. But that is not really happening that easily. It's a supply and demand, it's a chicken-egg problem. I personally think that there's a lot of merit in the end for hydrogen if we can produce it in a sustainable way and really get the infrastructure somehow going. Over there, please.
I have a very pedestrian question.
Good.
Are there any automation capabilities of interest in current models, 2014 or 2015? I noticed Mercedes sort of talks about it in some of their ads. And
yeah.
Do you view certain car companies as being in the near term leaders on this, or are they all researching it?
Yeah. Let's see. So there are definitely already what by the definition would be called automation now coming to the vehicles. And the best and probably the real first example is the traffic jam assist, which is that this vehicle uses radar, some cameras to automate steering and braking and acceleration, that the vehicle can basically go at relatively low speeds in a densely trafficked area. And before that, we have what is called driver assistance topics. So that is adaptive cruise control, that is lane keeping assist and lane departure warning. So what I painted here as the steps into automation is basically, let's say, the second half of a journey that started more or less with ABS, anti-lock braking system, then stability control system, and then night vision systems, and so on. So there's quite a trajectory on these driver assistants and now low level of automation systems. And to your question, who are the leaders in this? Basically, what we've seen who brought the first driver assistance systems to the market, you can see those same companies being still very, very active. And I'm biased, of course, when I tell you that German products are very, very good. But they are always worth the consideration. We go here, and then we just alternate.
Thank you. Can you hear me?
Yes, I can.
Okay, good. I really appreciated your talk, and it gave me a fuel for my next white paper, okay? I want to do one thing real quickly for everyone. Would you raise your hand if you personally know of anyone that has been killed that you know?
In an accident, yeah.
Just raise your hand. How many people?
In a car accident, yeah.
In car accidents. This is a small gathering. Take a look at the hands.
Yeah.
Now, let me go back to your original point. You indicated 35,000 Americans, people, a year. And what I came away with, as both, by the way, is both a design engineer and a human factors engineer, we're working on the wrong problem. I think I was very impressed with what I saw. The concentration is an engineer's concentration on energy, highway, automation, electrification, and emission. But I don't see anything with respect to people, because if we're losing $35,000 people a year, there should be a mandate to the car industry that says, stop losing these people. And next year we want to see a loss down to 10 or 15 and keep going it that way. They don't have to pay for it. How do you do that? You do that by the same kind of innovative thinking that's been applied in this direction, and it's an area that hasn't been addressed. For example,
Yeah, so what is the question? Because we have other people
my
waiting
point,
for your
okay, my
question.
point is that we could direct that to people who already have a propensity for actions. We could direct that and know exactly what drivers are. We can put that on the dashboard, and we can turn that to a...
I agree with you. Yeah.
Okay, so that's basically my point.
Yeah,
Thank you.
Thanks for sharing that. Yes.
Hi, I have a three-part question. First of all, what's the status with fuel cells? Second one, with all these, especially with the radar sensors, how do you when you have thousands of cars with their own radars, how do you prevent interference between them? And second, and third, when you talked about Wi-Fi and cellular communications, how do you secure it so that hackers don't take the system over and then create a big traffic jam or car crashes and things like that?
Yeah, all very, very valid points. And on the fuel cell, I did say at the beginning that I'm focusing on electrification. I should have pointed out that maybe the end goal of electrification might be hydrogen, which was asked already earlier. And there's a lot of work on the fuel cell, and it's very interesting for me to observe this in the industry and also how the media covers it. That now it seems to be the time. Toyota, for instance, is getting even more active now in fuel cells, because they say, well, battery electric vehicles, we don't really see a battery revolution anytime soon, but at the same time, fuel cells are getting smaller, getting lighter, don't really need that much ramp up time anymore. So in the fuel cell, again, there might be quite a bit, again, similar to the question what was asked about hydrogen. On the radar, how these radars work, they basically send out a pulse with a certain code in it, so that you basically know, okay, this is what I sent out and now it's coming back, that you know when your own signal comes back, so that you're not reading the radar signal that's sent out by another vehicle. So that's basically figured out for now. It might be very well be a situation if all of a sudden all vehicles have, we are talking in the order of 2 to 4 radars maybe per vehicle, that all this gets congested and maybe that we need to figure out something. But for now, that seems to be okay, and the industry is taking this seriously. Also taking seriously the cybersecurity of the automobile. And this is now a mechanical engineer talking to you, where my personal take on this is, well, there's so many systems in our lives today that are computerized, that use wireless communication and so on. And mostly they work. And what I mean by that, I read an article just the other day that someone hacked into the traffic system of, I'm not sure if it was LA or New York City, and basically could control some of the traffic lights. It can be done, but someone can also break into a house and steal money. And if someone wants to manipulate automobiles, you can, don't do it, and don't tell anyone that I said this, but you can just snip the brake hoses of a car and manipulate it. But I also want to be so naive to basically say it doesn't really matter, because with a wireless communication, you can just be standing on the roadside and just see what happens. you don't even have to leave fingerprints on the vehicle. So I don't want to be so naive and say it does not matter. But I can assure you that the automotive industry, and also we have quite some researchers, Dan Bonnet comes to mind at Stanford University, really looking at cybersecurity and what it means to the automotive industry. Because if there's just a little bit of a doubt that not everything was done in order to make these connected, computerized, automated vehicles safe, then it just comes back to the car companies, which we saw in a very recent history with recalls and everything. So all points very well taken, and I guess I would say relatively well addressed by the industry. Let's go over here.
Okay,
again.
so I have a practical problem. So I live in City A, but I work in City B. And I got to go back and forth twice a day, and it seems that everybody else wants to go back and forth at the same time I do. So we have traffic jams. I've been told that the promise of the automated car is to increase the capacity of our freeways, highways, streets, such that instead of building additional lanes on 101, we can remove lanes on 101 and convert them to bicycle, walking, etc.
Sure. So that is one piece. If we were to look at the four main motivations for automated vehicles, so I talked a lot about safety. I didn't talk too much about efficiency. I didn't talk too much about extended mobility for the elderly and so on. I didn't talk too much about convenience. But if we were to talk about the efficiency, it really is that you can space vehicles closer together, and therefore you gain a lot of surface area and therefore get more throughput on the highway. But still, it makes me crunch, honestly, because that means creating more traffic. I rather want to ask everyone else who maybe is also going from City A to City B if you maybe cannot team up and still enjoy the ride in an automated vehicle, because it might just be a short-term solution. And the answer is yes, that can help, because humans have reaction time 1 second and up. Computers with very good sensors probably have less. And therefore you can space vehicles closer together, and also laterally that we don't need that much space left and right because these vehicles are more precise in the lane keeping. But still, this is just patching the problem, I guess. Okay?
Has anyone estimated the percent reduction in imported oil that would result from about an 80% adoption of extended range electric?
There are estimates, but I don't have these numbers with me. You said 80, what did you say, 80?
Some number.
80% electrification, they are significant, yeah. Because you typically don't generate electricity from oil, not to a large extent. I mean, even coal, which is domestic. If you're talking about foreign oil, electrification helps a lot.
I'd like to address the ecology of electrification in automobiles. You made a statement that because you have electric cars, the pollution doesn't exist in the dense cities, but you're generating the electricity outside the city. Mm-hmm. But pollution is a global thing, not a regional thing, mm-hmm. I don't think.
And I agree with you. Let me just answer this right away. This is really where we need to look at the different kinds of pollution. So carbon dioxide emissions obviously are global. Otherwise, we wouldn't call it global warming.
But in generating electricity, mm-hmm. you have that.
Absolutely.
Okay.
Yeah, of course. But it is something, I'm not saying that it's good, but it does make a difference if you have the emissions, especially volatile organic compounds, so basically unburned fuel, soot, and particles, and so on. If you have this in the city or outside. It still exists, which is bad. Don't get me wrong.
The winds blow across the oceans. Mm-hmm. We get pollution from far away. Okay. The other thing is that you've got to talk about this electrification from inception to the final retiring of the electric car.
Yep.
Not only the generation of electricity that it needs, but the batteries and the disposal of them.
Correct.
You know, the ecology of electricity you didn't state clearly. I think it's a real problem.
I'm sorry if you didn't understand me. I thought I was making myself clear when I really hailed the work from our friends at Carnegie Mellon University. They're doing this life cycle assessment where they're really taking everything, the entire life cycle of the vehicle, including the recycling, and where they say a huge battery is not a good solution. Where they say a small battery with a range extender is actually better because having these batteries, and we need to see what we do with it, and still there are businesses being created because we can use these batteries to stabilize the electric grid that obviously fluctuates now much more because of the renewables, and that we can do something there. That is good, but I absolutely agree with you. It's not just what is called well-to-wheel, so we don't really end with the upstream. We have to go downstream, wheel to grave as well. So basically what happens when the vehicle is being decommissioned. You're absolutely right.
Not surprisingly, your talk focuses essentially on an urban vision for the automobile, or focus on it. How about for small cities, something like a Chico or a trip, across the Yosemite we enjoy? How's without the range extender is obviously a big possibility. Or
I think
big
so.
thing, right?
And the problem is I didn't get to show slide number 54, which is this, where I basically say, we really need to look at like two additional axes. One is the population density on the horizontal, and on the vertical, the infrastructure that is deployed. And therefore, you're absolutely right. It's, I don't just want to look at mega cities. For instance, San Francisco is by no means a mega city, but still has a lot of transportation challenges. And definitely don't want to stop at the limits of a metro area. So if that's cities like Chico or even smaller, if it's somewhere out in the rural areas where people want their mobility, need the mobility to get to work, where public transportation is not as well deployed as maybe in the urban areas. So it's basically saying we really need to look what are the solutions we want to deploy for a certain use case. This is why I say I don't just want to look at the automobile. I want to look at the mobility user, where you're absolutely right. It obviously matters a lot where that person is, what the person's lifestyle is, what that person's profession, commute, and so on is. And where we really need to think what the automobile used to be, a one-size-fits-all or the Swiss Army knife. Whatever you want to do, if you want to go to Home Depot or the opera or pick up the kids or go to the beach or go to the mountains or do whatever, go to work, the car does it for you. And that might not hold true going forward anymore, that we really get more specialized and really not just the automobile, the mobility solution, which maybe it's not an automobile anymore. Maybe it's a bicycle, maybe it's the bus, maybe it's a ride-sharing system. But we really need to see, you're absolutely right, what is being deployed in a certain area. And it will not happen all the time, not happen everything at the same time and not at the same place. That's right.
There's a significant expense of an automobile that you didn't cover here, and that is the insurance and personal responsibility, and how what might occur as automobiles become more automated.
That is correct. I did not specifically talk about this, and some people say that the insurance model might be the solution to automation. That basically you just factor it in, that you have higher, maybe lower insurance premium for automated vehicles. But it's really hard to tell if insurance premiums should go up or down for these automated vehicles, which some of you might maybe know when the first anti-lock braking systems were launched into the market, that these vehicles had now the super brakes and insurance premiums went down until basically what's called risk homeostasis or risk overcompensation, that the drivers basically thought they basically have great stopping performance and they were driving more recklessly. Actually, insurance premiums went up later on again. So therefore, it's definitely an important factor. I just got my insurance bill for my car today. And it's too early to tell where this might be going. But it's, again, another point. We are not just done once we designed a vehicle. So much more actually applies to it. And it's a very good point.
You did some very nice engineering analysis, very hard engineering. But you've seem to have glossed over one point that I think will increasingly become more and more important. All of these mechanisms that you talk about, hears all, sees all, knows all, and blabs all. Do you really trust Sacramento or Washington to not grab that data and either sell it to a marketer or post it on the internet that you stop at Lucy's Lovely Lady Lounge every night for an hour and a half?
Yeah,
Or better yet, Biff's Bar.
yeah. No, you're right, you're right.
I mean, I see no way to make this work
Yeah.
without the accumulation of data that will come back to haunt you.
Yeah.
Do you want a vehicle like that?
Yes, and we have few people safe in here, I believe, right? It doesn't work. No, it's definitely an important topic, you're right. And let's say just because a vehicle is automated, it doesn't mean that the data is really shared. I do propose connected vehicles, yes, but I want to be clear. The automation as such doesn't have to do much with where the data goes, because that is, for now, if we talk automation, within the vehicle. Once I talk connected vehicles, yes, that's the same as if I assume, do you have a smartphone? Yeah. So you're connected to someone's server, someone knows where you are. The automobile is one additional thing. Again, I don't want to be naive. Driving a car is something different than having your smartphone in the pocket. But guess what? You came with a car. So Sacramento or whoever might know where your car is, but if you're AT&T, Verizon, whatever, knows where you are. So you can. Yeah. Unless you clip the wires, probably. That's correct. Mm-hmm. 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 So what do we do? What do you propose?
I drive old cars.
Okay. One solution. Okay.
To what extent, if any, and I've heard this reported, that CAFE standards have contributed to automobile deaths. Are you aware of that? Do you agree with it? What's the extent?
I know about these statements, and I find them very challenging, I have to say, and also disturbing, because if there is an understanding that I don't even want to pronounce, I much rather want people to understand that many different characteristics and attributes define a vehicle. And I personally don't think making it heavier makes it automatically safer. I come from a background, I told you on my second slide, I think, my education, mechanical engineer and so on. My education was about avoiding accidents and not just about surviving accidents. And avoiding an accident, a smart, lightweight, and maybe efficient vehicle is actually a very good option. So I don't agree with that statement.
Rather avoid it, absolutely.
Mm-hmm.
How many people in the room have heard about the accumulation of ice in the Great Lakes this past winter that have resulted in starvation of ducks? Have you heard any reports on that?
I haven't heard about...
Look it up on the internet.
Yeah. Please.
Earlier you showed a picture of...
Can you speak a little bit closer to the mic?
Earlier you showed a picture of sensor fusion with
Yes.
cameras, radar, LiDAR. The chips to process those are obviously pretty complicated, and protecting them from radiation faults is getting harder. Is there any research that's going on at Stanford to do something other than just redundant systems to protect against radiation bit flips?
Well, I mean, there's definitely some work on electromagnetic interference and things like this, what that causes to the controllers in the vehicle. We saw earlier, or I think it was after this slide, but earlier in my talk here, that there are today already up to 80 control units in the vehicle. And when electronics was still relatively new in cars, so it did happen that in some certain locations, the ABS controller went boo-high. And later on, they figured out, it was right around the time when the first cell phone towers were implemented. Then they figured out, well, basically it was radiation from cell phone towers that made a bit flip or something like that. I think that there might also have been some airbag deployments with no reason other than it must have been electromagnetic interference. So it's another important topic in the industry.
I was talking more about cosmic radiation. Those are the biggest cause of like the unintended acceleration.
I'm not an expert in that field. I don't know, but I'm sure that that is also something which is being considered because, as you say, it might be a very important cause for interference with electronic systems. And I'm not quite sure to what extent that would be specific to automation, other than we get even more computers in the vehicle.
Okay, thanks.
Okay, sure. Okay.
So I'm just a little bit concerned about the first time that somebody dies in an automobile accident because an automated car had a bug in its code. As a software engineer, that's absolutely certain to happen.
Mm-hmm. It is. It is. So we are definitely, unfortunately, we are certain that also automated vehicles will not be able to eliminate all accidents because there's no technology on this planet that is 100% safe, which we saw, unfortunately, with Fukushima a few years ago. But even that technology, it is not safe. Things can happen. It's a question of how many nines behind the dot in percentages. And that will happen, and then one might ask the question, what was the cause? Was it maybe a human-driven vehicle that basically got in the lane of the automated vehicle? But it can even be that the owner of that vehicle didn't clean the lens of the laser scanner in the morning, just as it reads in the operator's manual for the vehicle, because no one really reads the manual for a car. So these things will happen, and then the question will be asked, well, who is liable? And that is quite something where I also showed that the research at Stanford, legal aspects of automated vehicles. I want to answer it. I don't have a solution for this because, I mean, lawyers would say, well, it depends. Let me look at all the information and so on. But an example that I want to give you from Bryant Walker-Smith, who's working in this field, he also looked at the data component again. So what it actually means that the car company knows about what's going on in the car and knows maybe that the brake pads were worn down and something like this, but didn't actually notify you. You know what, if you just drive 1 extra mile, you're really in trouble. So that is also something where with all this technology, liability might shift and might actually build up because you have knowledge about something and you're not taking action. It maybe creates a challenge then. But definitely if these accidents happen, it will be looked at what was done in order to prevent this. And we know from the history sometimes there's a smoking gun, where it's then, they actually put the economics over safety, and that doesn't look very good.
Which is related to this one also. I mean, mine was more simple. Let's say that assume that in 5 years the Google or automated vehicle become a reality and kill somebody. Who pays? Who is responsible? I mean, the owner, the car company, the software company, and who is legally responsible?
This is one of my favorite questions. Let me answer the following way. You drive a car? This is an example. Let's assume an accident happens to you. Hopefully it won't. It's just an example. Who will be liable on your way home, an accident? No, it depends. It depends on the kind of accident. Certainly, if it is something, you mentioned one company, if they make a programming error, it's like, I thought you changed the minus. No, I thought you did. Then, sure. But if it is something that someone jumps in front of the car, and therefore the car does the best to its capabilities to avoid the crash with me jumping in front of this automated vehicle, and therefore it crashes into another car and someone gets injured, who's liable? Me jumping in front of the car? Maybe. So it really depends, and this is where I really find we cannot just say automatically, it's an automated car now and all the liability goes to the manufacturer. Yes, certainly the manufacturer bears more of the responsibility because the manufacturer, and by the way, also maybe the data provider, maybe also the infrastructure provider, is more involved in the driving process. Where right now one can say Sven drove the car, so therefore Sven assumes a lot of the responsibility. But it's not automatically just because it's an automated car that the manufacturer or the supplier or the data provider is automatically liable. You're welcome. Thank you.